Hello and welcome everyone to a new semester and specifically to physical geology class. I'm your professor, Lisa Levy, and it's my honor and privilege to be your guide for the next few months through what I hope will be an enjoyable and informative look at the processes and features that make our Earth a livable and beautiful place. Let's begin with a satellite view of Earth from space. You will notice that the view isn't centered on North America. You're looking at Asia, Europe, and a portion of Africa. In this image, we can see the overwhelming blue of the oceans, the brownish colors of deserts, the green of vegetation, the white of ice caps, islands, and huge land masses. This collage of features and colors make up Earth. Earth is our support system. It provides all the resources we need to exist. But resources are not infinite, and Earth is currently supporting approximately 8 billion people, all needing resources, but some of us hogging more than others. All the systems in place that make up Earth are interlinked, and we as humans are part of those linkages. That's important to understand if we want to keep Earth a livable place for future generations. She is all we have. As the saying goes, there is no planet B. But even if there was, would we treat it any differently? I'm all for the space exploration we're engaged in, but Bill Maher, if you know who he is, has a very funny monologue with some pretty salient points about why it's crazy for us to be thinking about Mars as a habitable planet when we're sitting on a perfectly good one with everything we need if we would only start caring for it. Each chapter will open with learning objectives. This is the material on which you want to concentrate your study efforts. Don't look at them, recognize a few words, and think that's it. Think of these as essay questions where you need to expand your answer with supporting information to illustrate your knowledge of the topic. Since I strive for narrations that are not outlandishly long, and sometimes I accomplish that and sometimes I don't, but I will not go through each learning objective individually. But they will be in your notes and you can look at them at your leisure. For the sections in this chapter that cover the scientific method and layers and systems of the Earth, I'm going to use narrated lectures from my Earth Science class. Pay no attention to my mention of Earth Science, but after all, that's what geology is. But in Earth Science, we also study the topics of meteorology, astronomy, and oceanography. Don't get too jealous about that because we'll also get into the topic of astronomy in this class. In fact, it's the next chapter, which will be chapter 22. Earth is a system, and there are components to that system, and it's a pretty complex system as well. And some of the components of that system include the atmosphere, the biosphere, the hydrosphere, the lithosphere, the mantle, and the core, the liquid outer core and the solid inner core. And this I'm going to cover in a separate lecture, narrated lecture, and I will point it out in the notes in the module. This is the one where I said that I was going to use a narrated lecture from my Earth Science class. So I'll leave you with that. But let's look at what is geology. Geology, geo means earth, of course. Ology means study of, so it's the study of the earth. But we also have planetary geology, where we study planets in this solar system and planets throughout other solar systems and their moons. Geology is typically broken into physical geology, which is where you find yourself now, which looks at minerals and rocks and the physical processes that take place on Earth. Usually, people that have physical geology will go on to the next geology, which is historical geology. And that is where we talk about the origin of the Earth, evolution of life on Earth. But there are many other types of geology too. There's resource geology, there's environmental geology, there's medical geology, and it goes on and on and on. There's glaciology, which is a component of geology. There's volcanology, where you get really specific. Okay, you're studying either glaciers or you're studying volcanoes. And there's also, of course, paleontology, which is the study of fossils. So it's a wide-ranging science. Geology is eclectic. If you ever watch The Big Bang Theory, you know Sheldon was always dissing geologists. Remember Bert that worked in the lab, always giving him a hard time. Well, Sheldon was a physicist, and physics considers itself to be one of the classical sciences. So other sciences, like geology, pulls from physics. When we say that geology is eclectic, that means that it's diverse, it's broad, it's comprehensive, it's general, as opposed to the opposite of eclectic, which is narrow, rigid, confined, limited. Geology isn't. And one of the reasons that it isn't is because it pulls from all these other sciences. We need other sciences in order to study how the Earth works. Think about a paleontologist. A paleontologist studies ancient life forms. Well, life, there you go. You're going to have to know something about biology. And if you're looking at organisms and you want to know how they work, you're going to have to know something about anatomy. And if it's plant fossils, then you certainly have to know botany. Geologists that study the interior of the Earth, most earthquake scientists, they are using physics to do that. In fact, there's an entire branch of geology called geophysics. There's also an entire branch of geology called geochemistry. Well, that makes perfect sense because we study rocks and minerals. What are rocks and minerals made from? What are minerals made from? Well, they're made from elements that combine. What are elements made from? They're made from atoms. Where do you go to study how substances combine and how they combine and what happens when they combine? Chemistry. So geochemistry. We have geologists that are climate scientists, so they have to know something about meteorology. And then hydrology, that's a geologist that studies water. Go to any irrigation district or any agencies that are tasked with monitoring water. What do they have on staff? They have hydrologists who are geologists. And it goes on and on and on. So you can see, you can pick whatever field you want to be in. If you want to study glaciers, then you can be a geologist, a glaciologist. You want to study volcanoes, you can be a volcanologist. And geology is one of the sciences that is most directly related to environmental issues, studying environmental issues like resources. Where are they? How are you going to recover them? What do you do after you recover them? How are you going to remediate the land? Natural hazards and planning. And it, again, goes on and on. So there's something for everybody in geology. That's what I'm trying to say. There's something for everyone. All right, I'm going to stop here, and I will see you next time. What we're going to cover next. I think the scientific method is the next narrated video. So talk to you later.